This is a standard projectile question where you need to resolve forces and solve for time to work out the time taken for the projectile to return to the ground. So we are given the launch speed, and we can use that to find the time that the object is in the air. So the launch speed we're given is 25 meters per second, and it's an angle of 35 degrees. So if I draw that, I sketch that for myself to help my working. So we've got 25 meters per second, and the angle is 35 degrees. Now, I know the vertical component of velocity. I can work out the vertical component of velocity there. So I can treat it's the vertical component that we're interested in to solve this, to work out how long it is in the air. So it's the vertical component that affects how long it's in the air. The horizontal component, although it affects how far it goes, it doesn't affect the time it's in the air for. So we are looking at the, I'll call it Vy. So we use the standard graphical notation for that component there. So Vy is going to be 25, and then we just need to remember whether it's sine or cos, and I would consider it away from the angle, so it's sine 35. So I can calculate that. So 25 times the sine of 35 gives me 14.3 and some other numbers, 13.339 and some other numbers. So that's in meters per second, and that is my initial vertical speed. So it's going. We can treat it as if it's going straight up at 14.339 meters per second, and we can now solve for time. So there are a number of things we can do, and it's understanding the physics of the situation, understanding what's actually going on. So I can go for, I'm interested when v equals the negative of u. So when it goes up in the air, it'll come back down, but the velocity is in the same magnitude but in the opposite direction. I can solve for when is this true, at what time is this true. So v equals u plus at, I can use. I know a because it's on planet Earth, so I can use 9.8 for a. So we've got when is v negative u, and I'm trying to find t here. So the v value, the final speed is negative 14.339, etc. And then I can move the u to the other side, and I get negative 14.339, etc. is equal to negative, because it's downwards, I'm taking downwards to be negative, 9.81 multiplied by the time. So effectively, I'm just multiplying that number by 2. So we get negative 28.678 divided by negative 9.8, and we should get a positive time, which would make sense. So we get that divided by 9.8 gets me a time of 2.93 seconds.